Juga kita seharian di kelas kan, di Zoom. Ya, oke. Nah, makanya saya selalu bilang ke kalian, ya, jauh-jauh hari pelajari, ya kan? Saya selalu bilang gitu. Nggak akan mungkin selesai, saya nggak mungkin menyelesaikan di kelas, ya. Nah, saya usahakan, tapi kalian juga harus berusaha. Oke? Nah, oke, let's start. Okay, I'm doing my introduction with Indonesian, with Bahasa. Now I'm changing into English again because you guys are in bilingual class. Now we are in sulfate anion analysis. Okay, we are already in sulfate anion analysis, and let's see what are the group, what are anion that are categorized as sulfate anion. Okay, now you can see here there are 6 anion that are categorized as sulfate group. That is sulfate, carbonate, phosphate, chromite, oxalate. Oxalate, this is oxalat ya, kalau bahasa Indonesia oxalat. Oxalate, and then sulfate. Yeah. Now, so all these 6 are categorized under sulfate group. That's the reason, yeah. That's the reason that I have 100 slides. I know that it's impossible to finish it, but like even half it, we can finish it. It's already good. Okay, so this is the sulfate anion sulfate group, yeah, and we will see how we can analyze all these 6 sulfate group using chemicals. Okay, finish this. Finish. Okay. Now, so the first anion that we will be discussing is sulfate, O4 minus, yeah, sulfates, SO4 2 minus. Okay. Now, for sulfate, you can see here, if sulfate combined with barium, strontium, and lead, they are insoluble in water. So one way to identify sulfate is by reacting sulfate with barium, strontium, and lead. And you will see a precipitate there because these 3 salt, yeah, because if you combine cation and anion, you will form salt, yeah, and all these 3 salt insoluble in water. Okay, practically insoluble. So it's quite different from calcium and mercury, because calcium and mercury is slightly soluble. So it means like a little bit of it will be soluble, but not the whole of it. Okay, so this is totally not soluble. This is slightly soluble, and the rest of cation will be soluble in sulfate. So I think last week we are studying group 5, right? Group 5, group 4. I don't remember barium and strontium and lead is in which group, but you will remember that some of cation, when you mix it with hydrogen sulfate is not reacting. Yeah, so it means it's not soluble. So this is practically insoluble in water. Yeah. Whereas calcium, mercury, slightly soluble, and the rest of metallic sulfate are soluble. Okay. Finish this?
Finish, ma'am.
Okay. Now, So if we have a mercury sulfate, bismuth sulfate, chromium sulfate, we call these three are basic sulfate. Yeah, basic sulfate. And this basic sulfate also insoluble in water. But when you mix it with hydrochloric acid or nitric acid, this sulfate will be soluble. Yeah, so if this mercury sulfate, bismuth sulfate, chromium sulfate, you mix it with water, will be insoluble. Yeah, but if you mix it with hydrochloric acid or nitric acid, it will be soluble. Okay, next, let's continue. Yeah. Sulfuric acid. Now, since we are studying about sulfate, right? Of course, we need to know about sulfuric acid because sulfuric acid is the source for making sulfate anion. Now, the physical characteristic of sulfuric acid listed in the slide. In this slide, okay, the first one is colorless. The second one is oily. The third one is hygroscopic liquid. The fourth one, it has a specific gravity of 1.838. So I guess you guys already going into the lab and look at directly how is sulfuric acid, right? Of course, you cannot touch it, right? You cannot touch it because this is a strong acid. But based from what you see, you know that sulfuric acid is quite different from water, because water is basically more clear, right? If you compare it with sulfuric acid is not as clear as water. Okay, and then if you kind of like use stirring rod to what house to mix it, right? You can see that the density, the sulfuric acid is more dense compared to water. Okay, so this is the physical characteristic of sulfuric acid. Now, you can see here, if we buy sulfuric acid, yeah, usually it will be, we can have a pure sulfuric acid, and it has a constant boiling point of 338 degrees Celsius. And 338 degrees Celsius usually contain 98% acid. Okay, it has slightly maybe other contamination, but we call 98% acid. We consider it as a pure. So when we buy it, usually it says like 98%. Yeah, 98%. So it's quite impossible to buy like 100%. Okay, similar with ethanol. Yeah, you never buy 100% ethanol. It's always like maybe 95%. 95% is already really, really good for ethanol. Okay, finish this?
Finish.
Okay, now this is sort of like a basic lab knowledge for you guys. Yeah, so when you need to mix water, with sulfuric acid, how do you mix it? Do you put water into the sulfuric acid or the sulfuric acid into water? How do you mix it?
Sulfuric acid into water.
Into water, ma'am.
Sulfuric acid into water. So never ever put water into sulfuric acid. Why? Because if you mix sulfuric acid with water, it will generate heat. Yeah, it will generate heat. So that's why here the acid should always be poured into a thin stream of water. So don't put a lot, yeah. So never put it like suddenly a lot of it. So put it like gently, a little bit, little bit like that. Okay, because if you put it like suddenly a lot of it, it's still like it's dangerous, right? Because what we have is, you can see here, actually sulfuric acid is miscible with water, miscible, yeah, miscible, and then when it's mixed with water, is generate heat, yeah, generate heat. So that's why if you change the way you pour it down, then it will be dangerous for you. Okay, so keep that in mind. Yeah, don't put water into sulfuric acid, but you have to put the sulfuric acid into water, but put it like little by little. Okay, don't put like the whole bottle suddenly. Okay, it's not good. Okay, so that's why here is on mixing the two, the acid should always be poured into a thin stream, into the water. So little by little. Okay, now, so this is a warning, like I mentioned, right? If the water is poured into the heavier acid, then it will generate heat, steam, and if you're not aware of it, it may be like it will blow up, right? And then it will touch your skin and everything, so it's dangerous. Okay, so so this is a good basic knowledge for you before going into the lab. Okay. Okay, now, so the first one is barium chloride solution. Okay, so if you mix barium chloride solution with a hydrogen sulfate, it will it will form a white precipitate. Yeah, the white precipitate will be identified as a barium sulfate. Okay, now this barium sulfate, yeah, it's insoluble, yeah, so pay attention, insoluble in warm dilute hydrochloric acid and dilute nitric acid. So it means it won't be soluble, but yeah, you can see in the picture also, it will be moderately soluble when you boil it. Yeah, so for example, this is you heat you heat the hydrochloric acid like a little bit, not until the boiling point. Not until the boiling point. So the barium sulfate won't be soluble. But when you heat the hydrochloric acid until its boiling point, until it has bubble, and then you mix with barium sulfate, then the barium sulfate will be soluble like this. So you need high temperature concentrated hydrochloric acid to dissolve barium sulfate. So that's why I put like a picture here, so that you can imagine what what is the physical appearance of the barium sulfate. Yeah. Now, finish? Not yet?
Finish.
Okay.
Yes, ma'am.
Okay, I think Nia said she hasn't finished. Okay. Okay. So this is barium chloride, right? Now, this is the reaction. Yeah, sulfate anion. You reacted with a barium cation, and the barium sulfate will be formed. And you can see here, it has a down arrow, meaning there will be a precipitate, and the color of the precipitate will be white color. Okay, now, so let's see here. So if we have dilute hydrochloric acid, right? Dilute hydrochloric acid. Now, this dilute hydrochloric acid, there are three anion that won't be dissolved in it. So for example, carbonates, sulfites, phosphate. So these three are not precipitated under dilute hydrochloric acid. Yeah, carbonates, sulfate, and phosphate. Hold a second, okay? Someone seems knocking on my door. Sorry, yeah. Okay. Now, next. So if we have concentrated acid, yeah, in this case, concentrated hydrochloric, concentrated nitric acid, then we cannot use it. Yeah. Why? Because barium chlorate or barium nitrate may form. Yeah. Then it means barium chlorate and barium nitrate will be in the form of precipitate because when we mix it, it will have a barium chlorate or barium nitrate. Now, but the good thing is barium chlorate and barium nitrate will be dissolved using water. Yeah. Okay, finish this. Now, next is sodium carbonate. Now, if you have barium sulfate, remember barium sulfate will be in the form of precipitate. Yeah. What you can do is first you filter the precipitate of barium sulfate. Yeah. You will take the precipitate from the mixture, right? And then you put it in the charcoal, yeah, charcoal. So it means you mix with sodium carbonate, yeah, and sodium sulfite will be formed, yeah. So upon mixing with charcoal and sodium carbonate, you will have sodium sulfite. Now, sodium sulfate here, right? You can extract it with water, meaning that the sodium sulfate will mix with water. Yeah, will mix with water. Okay, now, so the extract here, okay, so remember we mix sodium sulfite with water and we call it extract of sodium sulfate in water. So the extract, yeah, you can filter it again. Yeah, filter it and then you mix it with sodium nitroprusside. And when you mix it with sodium nitroprusside, you will have a purple color, a transient purple color. So this is one way of identify sulfate anion. So you mix with barium sulfate, it will have a white precipitate, right? And then you fuse it. It means you combine it with sodium carbonate. Yeah, sodium carbonate. By fuse mean you combine it by heated, yeah, on charcoal, then sodium sulfite will be formed. This sodium sulfate, you mix it with water, right? So it means you put this sodium sulfate into water, and then you filter it, yeah, mix it again, mix the filter, the extract filter with sodium nitroprusside, then you have a transient purple color. Okay, so that's one process of identifying sulfate anion. Okay, now that's one way to identify sulfate, right? Now another way is you mix barium sulfate with hydrochloric acid, right? And when you mix it as an solid, yeah, as a solid. So that's why this is it called fuse mass, right? And then you cover the container with lead acetate paper. As time goes by, the lead acetate paper will change into will have a black stain. So it has some black stain in the paper, and the black stain, we call it lead sulfate. Yeah, lead sulfate. Okay, so you mix very dilute hydrochloric acid to the barium sulfate, and then you cover with lead acetate paper, and it will have a lead sulfate in the paper. Okay, finish? Okay, next, we have what we call HEPA reaction. Yeah, HEPA reaction, it is less sensitive. Yeah, less sensitive. How we do HEPA reaction is by placing, yeah, fusion product on silver foil. So we have a silver foil. We put like a little bit water, in the silver foil so that the silver foil will be moistening. And then once we mix the silver foil and the fusion product, then it will have a brown black stain. The brown black stain is identified as silver sulfate. Yeah. Okay. Now, so this is the reaction. Yeah. Barium sulfate, you add with carbon, you add with sodium carbonate. Yeah. You have sodium sulfate, you have also barium carbonate, and then it will release carbon monoxide gas. And sodium sulfate, it can become 2 sodium plus sulfate anion. Yeah. The sulfate anion, you react it with the silver, remember the silver foil, and it will form silver sulfate. The silver sulfate will be in stain, black stain color, and it will have 4 hydroxide anion. Yeah. So this is the reaction step of HEPA reaction. Yeah. Okay, finish this. Finish.
Finish, ma'am.
Now, so now how we can decompose sulfur compound? Yeah. So first, if we want to decompose sulfur compound, first we can hit the sulfur compound with sodium or potassium. Yeah, with sodium and potassium. Now, this method we are using as a test for sulfite anion. Yeah. So we decompose. Finish?
Finish, ma'am.
Okay. Now, so remember, we can decompose sulfur compound by heating with sodium and potassium, and this is how we test the product of sulfite. Now, next, how we can test the sulfite product? Okay, first, the sulfite product is sensitive with heating. Okay, so once we burn it, right? We heat it with potassium in the ignition tube, then it will burn. And once it burns, we dissolve it in water. Yeah, dissolve the melting material into the water, and we mix it with nitroprusside or methylene blue reaction. Yeah. Our midterm is only until cation. Okay, so this material we will be tested later during final test. Okay, okay, but we still need to meet, okay, to meet our 16 times 16 class meeting. Okay, okay. So next, warning. So this is warning. So when you heat something, substance with a potassium metal, this is a dangerous procedure. Yeah, because potassium is basically explosive material, right? So that's why when you try to heat the sulfate with potassium, you have to wear appropriate equipment. Yeah, so you cannot just like, I don't think our lab have the capability to do this test. Okay, so this is should be in special room. Yeah, special clothes. Yeah, so warning, so don't ever do this by yourself. Okay, now next, barium sulfate. Now, barium sulfate here, yeah, if you remember, it will be precipitate in the presence of hydrochloric acid. So it means here, right? You can test barium sulfate using hydrochloric acid, because it means if you have something, some material that are mixed with hydrochloric acid, then it if it's not dissolved, then it is meant by Bila aja po. Bisa. Hold a second, okay? Since I am okay. Ambil aja. Kita tolong dibikin satu yang sama ya. Adik udah mandi tuh. Udah makan. Makan obat juga udah. Obat uap, bukan uap tadi yang ngapain? Uap, ada uap tadi di situ. Oh, jadi belum, coba tanya uap. Adik dia dikasih makan obatnya. Oke. Udah kan? There are so many distractions. Okay, so this test, yeah, you can use it as a confirmatory test for sulfate. Okay, now, so remember, lead sulfate also will have a white precipitate. Okay, now lead sulfate here will be soluble in hot concentrated sulfuric acid. So the first one is hot concentrated sulfuric acid. The second one, lead sulfate, will be soluble in solution of ammonium acetate or ammonium tartrate. Now the third one is lead sulfate, will be dissolved, will be soluble in sodium hydroxide solution. Okay, so three type of solution will dissolve lead sulfate. So remember, it has to be hot concentrated. So it means if it cold and then dilute, it won't dissolve lead sulfate. So it should be hot concentrated sulfuric acid solution. So mixture of ammonium acetate and ammonium tartrate, the second one. The third one is sodium hydroxide solution. Yeah. Okay. Now, so how about tetrahydroxoplumbate? Yeah. So tetrahydroxoplumbate can be formed if you mix it with sodium hydroxide solution. Yeah. So lead sulfate mixed with sodium hydroxide solution, then it will form sodium tetrahydroxoplumbate. Now, this sodium tetrahydroxoplumbate, once you mix it with hydrochloric acid, it will form a crystal lead. Yeah. So lead chloride will be formed, and the formation will be in the crystal formation. Yeah. And if you mix this with a mixture of acetic acid and potassium chromate, right, you will have a yellow color precipitate. And the yellow color is identified as a lead chromate. Yeah, lead chromate. Finish? Finish, yeah? No. So next, let's see silver sulfate. Silver sulfate. Silver sulfate, the color is white, and then it has a crystalline precipitate, yeah, and you can see the chemical formula is Ag2SO4, silver sulfate, and you can see here the solubility is 5.8 gram per liter at 18 degree Celsius. But this solubility should be from a concentrated solution. So basically, it has a low solubility because you can see here silver sulfate. It is making a precipitate, and the color is white. So all the the topic that we discussed until this slide so far is methods to identify sulfate anion. Yeah. So you can identify it with mixing with lead, sulfate, lead, right? Barium, chromium, and then this time you mix sulfate with silver, then you know it will form a white crystalline precipitate. So it means silver sulfate silver sulfate is not powder but crystalline. So you should differentiate between powder and crystalline. Now, sodium rhodizonate test. Sodium rhodizonate test is when you have a barium salt, yeah, you mix with sodium rhodizonate and it will form a reddish brown color precipitate. Yeah, so if you have barium salt, mix it with sodium rhodizonate and then rhodizonate, and then it will form a reddish brown. And if you mix it with sulfate or sulfuric acid, suddenly the color will be disappear, because it said here sulfate and sulfuric acid will cause immediate decolorization. Yeah, why it has a decolorization? Because once you mix these two and you add sulfate or sulfuric acid, the barium sulfate will be formed. Remember, what is the color of barium sulfate that we learned at the beginning of the class today? White color, right? White color precipitates. So that's why this sodium rhodizonate is one way to testing whether we have sulfate or not. By mixing barium salt. So barium salt is basically, we have a barium cation. We mix with sodium rhodizonate. It has a reddish brown color. And we mix it with sulfate or sulfuric acid, and it will suddenly, the color will be disappear. The reason the color is disappear because we have a formation of a barium sulfate that has a white colors. And we put a note here. This test is specific for sulfate. Yeah. So after midterm test, you guys already start the lab, right? Okay, hopefully what we learn from before midterm, yeah, they will have it in the lab, so you can like imagine what we already discussed during the class. Okay. Okay. Next. So testing process. Now let's see what is the testing process. So if we have a barium chloride, yeah, solution of barium chloride, you put a drop of it in the paper, yeah, filter paper, and then after you drop it in the filter paper, you drop a solution of sodium rhodizonate in the filter paper, and you can see a reddish brown spot in the paper. And after the reddish brown spot, yeah, form, you drop acid, yeah, acid into the paper, then you can see the color spot disappear. So this is how you do the sodium rhodizonate test. Yeah. So you use a filter paper. Filter paper, the color is white, so you can see once you mix the barium chloride with sodium rhodizonate, you can see immediately there is a spot, a reddish brown spot. So reddish brown spot may be like a color of blood, right? If you have a blood, yeah, the color is reddish brown. And once the reddish brown spot form, you drop acid into the spot, and suddenly the spot is disappear. Why the spot is disappear? Can you guys tell me why? We already discussed it. Why the spot is disappear? Huh? Why the spot is disappear? The disappearance of the spot is due to what? Due to the formation of
Barium sulfate, ma'am.
barium sulfate. Okay. So the disappearance, the spot is disappear due to the formation of barium sulfate, because the barium sulfate, the color is white. Mm. Okay. Finish this. Okay. Next. So sodium rhodizonate test, the sensitivity is 4 microgram sulfate. So it will be sensitive in around 4 microgram sulfate. So the limit is 1 in 10,000. So there is a limit, of course. If you have too much of sulfate, maybe the sodium rhodizonate test cannot be performed. Yeah. Finish? Okay. Now, the next test is potassium permanganate, potassium permanganate, barium sulfate test. Yeah. So if we have barium sulfate, yeah, barium sulfate is precipitate, white precipitate. You mix it with potassium permanganate, the color will be changing from white to pink. Yeah. Okay. Now, so the potassium permanganate here, right? The permanganate absorb on the barium sulfate precipitate, and the precipitate, you cannot reduce it by common reducing agent. So for example, if you have hydrogen peroxide, you won't be able to reduce the permanganate. Okay, so what you can do is you use excess potassium permanganate, yeah, then the excess potassium permanganate can react with the reducing agent, and once it react with reducing agent, it will form a pink barium sulfate. Yeah, pink barium sulfate in the colorless solution. So the potassium permanganate, you should use it in excess. It means a lot of it, in order for it can react with reducing agent, so that the violet it has a pink violet, right? The violet will change into a pink barium sulfate. Yay. Now, so this is the testing process, right? You drop three test solution into a semi micro tube, right? And then you add 2 drops of 0.02 molar potassium permanganate and 1 drop barium chloride, and you can see here a pink precipitate is obtained. Yeah, so you have a pink precipitate. Then you add 3% of hydrogen peroxide or oxalic acid solution, either of these two. You can choose it. So you can choose hydrogen peroxide or oxalic acid, and then you warm it in water bath. Then the color will be disappear. And then the color is disappear, but then if you centrifuge, yeah, centrifuge the mixture, then the color precipitate will form again. So the color precipitate is clearly visible. So at first, without centrifugation, it doesn't have any color. But once you mix it with a high speed, yeah, then the color precipitate is visible again. Okay. If nothing is changed, yeah, if everything is going into schedule, next semester we will learn about separation chemistry, and one of the topic will be centrifugation. Okay, so I don't know if I still teach separation chemistry, but if I'm the one who teach you guys, then I will be teaching one topic will be about centrifugation. Okay. Finish this? No, not
Finish.
yet. Okay. Now, so for potassium permanganate, the sensitivity is even lower. Yeah, it's only 2.5 microgram of sulfate. Yeah, and the concentration limit is 1 in 20,000. So even if you have 2.5 microgram of sulfate, you can detect it with potassium permanganate. Yeah. Okay. Next, we can use also mercury to nitrate solution to analyze sulfate, but it is poison. Yeah, so I don't think we will be using it in a regular lab class because this is a poison material. But once you make, so the characteristic for mercury to nitrate solution is yellow. Yeah, yellow. So if you mix mercury to nitrate solution with sulfate, it will form a yellow precipitate of mercury to sulfate. And you can see this is the reaction. Yeah, sulfate anion. You reacting with you reacted with mercury cation. Yeah, and you have a solvent of water. Then it will form a mercury to sulfate. Yeah, you can see here mercury sulfate to mercury oxide, and this is a precipitate, and it has a yellow color. Yeah, yellow color of precipitate. But this is a poisonous chemical. Yeah. So I don't think we will be able to do this in regular lab class. Yeah. Now, mercury to nitrate solution is a sensitive test. Why? Because like a little bit suspension of barium or lead sulfate, we will be able to identify it. Yeah. So not too bad. Like we already in Zoom meeting for maybe like 1 hour, and we finished 34 slides. So it's not too bad. Okay. Although I don't think we will be able to finish it the 100 slide, but at least maybe half of it we'll be able to finish it. Hopefully. Okay. So that's why I always told you guys, like even though I teach you guys in class, like most of the analysis, but there is no way I can finish it in the class, right? So your cooperation, yeah. So you should study it also by yourself by reading a textbook. Yeah. Okay, next. Second anion. Second anion is carbonate. Okay, so the first one we already study is sulfate, right? Now the second one is carbonate. Okay, carbonate. Carbonate is under sulfate anion group also. Okay, carbonate here, yeah, the solubility, it's all normal, yeah, all normal carbonate, with the exception of alkali metals and ammonium, are insoluble in water. So meaning all carbonate are insoluble in water except for alkali metal carbonates and ammonium carbonates. So this is also one way you can analyze carbonate. Yeah. So if you know that most of carbonate are insoluble in water, but to identify it, you mix the carbonate with alkali metal or ammonium, then you know it's soluble, then you know you have carbonate. Because the exception here is one way to analyze the anion. Okay. Finish this one?
Finish, ma'am.
Okay. Now, so if you have hydrogen carbonate or bicarbonate, you mix it with cation calcium, strontium, barium, magnesium, iron, all these will be in aqueous solution. So meaning calcium carbonate, strontium carbonate, barium carbonate, magnesium carbonate, iron carbonate are soluble in water because exist in aqueous solution. Finish?
Finish, ma'am.
Okay. Now, so if you have all this mixed with carbonate, it will form excess carbonic acid. Yeah. Now, excess carbonic acid will be formed in aqueous solution, right? And it will decompose when you boil it. When you boil it, when you boil the solution. Yeah. So it means like sometimes you need to heat the solution, then the mixture will be decomposed. Okay. Now, next, this is the reaction. So carbonate, calcium carbonate, you mix it with water and carbon dioxide, yeah. And then it will form a cation of calcium and hydrogen carbonate, hydrogen carbonate. Now, this is usually when you have it in ion, remember, then it is soluble. Yeah, it doesn't form a precipitate. Okay. Now, if you have hydrogen carbonates of the alkali metals, remember it is soluble in water. Yeah, because most carbonate are insoluble in water except for alkali metal and ammonium. Yeah, so that's why here hydrogen carbonates of alkali metal are soluble in water, but it is less soluble if you compare to normal carbonate. This is hydrogen carbonate of alkali metal. This is the example. So this is dissolved, but this is less dissolved compared to this one. Yeah. So if you compare this and this, yeah, calcium carbonate is normal carbonate, right? This is hydrogen carbonate of alkali metal, and calcium is one of the alkali metal. So this is more soluble in water compared to this one. Okay. Now, so the reagent to detect carbonate, the first one is dilute hydrochloric acid. So if you mix carbonate with dilute hydrochloric acid, it will become decomposed. And when it decomposes, it will release carbon dioxide gas. So you can see here carbonate, you add it with acid, and this is only dilute acid, and it will form a carbon dioxide gas. Okay, now, the gas that are formed here, right? We react with lime water or barita water, then it will form a precipitate. So this is the CO2. We reacted with lime water or barita water, yeah, then it will form calcium carbonate as a precipitate and or barium carbonate as a precipitate. So that's how you identify carbonate using dilute hydrochloric acid. So you mix the carbonate with dilute hydrochloric acid, it will form carbon dioxide gas. Then the carbon dioxide gas, you react it with lime water, right? And then once you react with lime water, it will produce a precipitate. Depend on the water, right? For lime water, you can it will produce a calcium carbonate precipitate. With barita water, it will produce a barium carbonate precipitate. Okay. Now, so we have several natural carbonates. So natural carbonate is, the example of natural carbonate is magnesium carbonate or magnesite, siderite, this is iron carbonate, or dolomite. Dolomite is calcium, magnesium carbonate. Now, these natural carbonate that are mentioned in the slide, you cannot react it in the cold. So when you want to react these three types of natural carbonate, you have to divide, you have to make the carbonate into a fine powder. And once the fine powder you mix with acid, for example, and then you have to increase the temperature of the solution in order for this natural carbonate to be reacted. Okay, finish this.
Finish, ma'am.
Okay, now, so this is the experimental setup for the barium water, yeah, for the barita water or lime water. So for example, you mix the carbonate with the dilute hydrochloric acid, right? And once you mix it, right, the gas that are, so this is you mix the carbonate with the hydrochloric acid. So you close the lid, right? You close this the test tube, right? And but you have some types of pipe going through the test tube, so that the gas, the carbon dioxide gas that are formed here can go through this pipe and go directly to the lime water or the barita water. So either way, you can use this setup or this setup. So there are two setups for the experiment. And once the carbon dioxide react with the lime water, then you will have a precipitate in here. Yeah, white precipitate of barium carbonate or white precipitate of calcium carbonate. Okay, finish? Okay. Now, so you can also, right, put a solid substance in a test tube or small distilling flask like this, right? And when you mix the hydrochloric acid, so immediately you put a cork, yeah, a cork, and the gas will evolve, yeah, will evolve. So that's why here the gas will goes through here and goes directly into the lime water. Okay, but there is a note here. Sometimes you need to warm the solution so that it will be faster for the carbon dioxide to form. Okay, without warming, maybe it will be formed, but maybe it took a long time. So that's why warming may be necessary. And then you can pass into lime water or barita water contained in the test tube, and you can see the precipitate will be formed. But then if excess of carbon dioxide are formed, yeah, if excess of, so you have a calcium carbonate also already, right? In the, I will explain it here. So here, right, you mix the carbonate with hydrochloric acid. It will form a carbon dioxide, right? The carbon dioxide will be goes through this pipe going through here. At first, precipitate of calcium carbonate will be formed, right? But over time, yeah, over time, the hydrogen carbonate of the calcium will be formed. Then suddenly over time the precipitate will disappear, because remember at the previous slide, remember this calcium hydrogen carbonate, yeah, this is also soluble in water. So you can see here, it formed calcium carbonate at first, right? You add more carbon dioxide because carbon dioxide is produced more and more, and suddenly the precipitate disappear because the calcium hydrogen carbonate is formed. Finish this one? Finish? Okay, finish, yeah. I assume it's finished. So if you have acid, yeah, stronger than carbonic acid, so it means the carbonic acid, in this case, the K, yeah, the Ka is 4.31 to times 10 to the negative 7. So if you have any acid stronger than this carbonic acid, you can decompose carbonate. Yeah, you can decompose carbonate. So for example here, if you have acetic acid, the K is 1.76 times 10 to the negative 5. Of course, acetic acid is stronger than carbonic acid, even though we consider acetic acid as a weak acid. So acetic acid can decompose carbonate, yeah, but boric acid or hydrocyanic acid will not decompose carbonate. So it should be acid that are stronger than carbonic acid. Yeah. All these are considered as weak acid, right? But the strongest acid compared to all the weak acid are acetic acid, because you can see the K is 1.76 times 10 to the negative 5. Yeah. Okay. You guys already start feel overwhelmed with all the information? Huh? Yes? Yes or no? Because it's too much, right? Even though I'm a lecturer, I understand that this topic, a lot of things you guys need to memorize. This is basically a memorization. Okay. So that's why I forgot, Yolanda, when will be when we will have our midterm test? What date is it? Is it Wednesday? Yeah, Wednesday. What time?
Wait, ma'am.
Huh? Wednesday? Wednesday, what time? Is it 10? 10 o'clock?
Thursday, ma'am.
Oh, Thursday. So Thursday,
At 10 until 11:40, ma'am.
10 until 11:40. So it's so it's it will be offline, okay? Offline. So make sure we have class for that. Okay, Yolanda?
For the class is usually in our class, ma'am.
In the regular class. Is it in the
Or
regular class? Okay. Will the bilingual department provide someone to proctor the test, or should I proctor the test?
I don't know, ma'am, because just
This is the first time you guys have a offline class, offline test? No, right?
no,
Last
ma'am.
semester. Oh, so usually when you have a offline test, will the lecture will the lecturer proctor the test, or someone else proctor the test?
I think it is according to the lecture, ma'am.
It depends on the lecturer. So the
Yes.
bilingual department doesn't provide anyone to proctor the test.
No, ma'am.
Okay, why I mentioned that, because the test is I have another test also at that time. Yeah, I teach Matematika Kimia, so I have two class teaching for that class. So that I know whether I should ask help from my student. Okay, so maybe I should ask help. Yeah. Okay. Okay. I guess we just stop it. Okay, until this, because I know this is Saturday, right? And then you have to prepare for your midterm test. Okay, why don't we stop it? You guys maybe take a rest for 30 minutes and then start studying for your Monday class, right? Monday you will have a kinetika dan kesetimbangan kimia test, right? That's also a difficult test. Okay, so why don't we stop now? We still have 10 minutes, yeah, left, but I guess I just let it you guys go. Okay, any question? So our test will be until group 5. Okay, the anion here we will have it during the final. Okay. Any more question? No more question. Okay, no more question. Good luck on your midterm test, and see you maybe in 2 weeks. Okay, bye.